Hi there, didn't realize you were watching. Welcome to this tutorial. This is pretty exciting. We'll be looking at some pretty interesting effects here and learning how to make VOPs and simulations in Houdini, and some weird freaky growth patterns. Okay, here we are in Houdini. Let's start with some really basic foundational knowledge. So I'm going to explain a bit about VOPs and simulation here in the beginning before we jump into the actual effect. If you already are familiar with that, feel free to skip forward a bit in the video. So in the lava lamp in my last tutorial video, I was talking about how we can adjust attributes using things like the attribute adjust VOPs to create different effects. So at the simplest version, we could do something like an attribute adjust color here. And I could switch this over to a noise, and I could adjust the color on my points. So that's really cool, but you'll quickly find yourself needing to have more customized setups. This is where VOPs and VEX come into play. So VOPs are really Houdini's sort of visual coding language for VEX. VEX is the coding language in Houdini, and VOPs is a node-based approach to VEX. Don't let that scare you. It's very, very much similar to using shaders or materials in other 3D applications. If you haven't done that, that's okay, but this is sort of a backbone way of thinking that applies to many, many different software applications. So super, super powerful stuff. So let's say we want to recreate this sort of attribute adjust color in VOPs. I'm going to go ahead and press tab and start typing VOP. And you can see we get multiple selections here. Really all of these are the same. Attribute VOPs, detail, point, primitive, vertex. They're just running over different parts of the geometry. If I lay down an attribute VOP, I can select which parts of the geometry this affects. But if I know I need to run over points, I could just put down a point VOP. And we'll be using primarily point VOPs for this. These come with multiple inputs. We are going to use by default the first input, but if you need to sort of pipe in different streams of data, you can. And that becomes more common as your setups become more complex. But most of the time, you can use just the first input by default here. So I'm going to double click on the point VOP and I will dive inside. So the point VOP is a folder essentially that holds this VEX builder context. By default, we're greeted by inputs on the left side in the form of position, velocity, force, etc., and outputs on the right side. This is just like a starter template Houdini gives you. You can bring in any sort of attribute, any data into this, and export any sort of data out of this. Excuse me. So let's try this. I'm going to use a noise here. So if I just start typing in noise, there's tons of different types of noises. I'm going to use maybe the unified noise here, and I'll use the static version since we're not animating it. And noise requires some sort of position to display the noise. So think of like textures. Textures need like UVs. You could use UVs to drive the noise, but in our case, we'll just use position. The 3D position of each point will then yield some sort of noise data. I'm going to take a sip of water. If I were an expert YouTuber, I'd probably cut this. We'll see if that stays in the edit. Okay. So I have piped in position here, and now I want to pipe in the output of the noise, which is this top dot here, into my CD or color diffuse. And you can see here that we get this black and white pattern. Right now, man. Right now, you can see my noise is set to one-dimensional, which just means black and white. We can experiment with a noise type. Whirly noise is pretty cool. We get this Verneuil cellular sort of look. And now let's say we want to have some customizability with the colors. So this is where I could add a ramp parameter. And this creates a ramp that the user can adjust to create whatever look they want. I could name this, I could call it color_ramp. And the label is what the sort of pretty name is with nice capitalization and spacing. So I'll call it color ramp. And now if I jump up a level, you can see I have this ramp on my VOP. So I'm creating a little user interface here. Let's say you wanted to make a tool to get handed off to another artist. This is a great way of going about it, using these ramps in your VOP network. So now I could click the gear here and click a preset. Let's go sand. And I've essentially recreated my attribute adjust color node. I could try this. Let's go with the infrared. And you can see by default, we're not really getting some of these red colors at the top of the spectrum here. One other good node, there's lots of nice nodes in VOPs, but one other very common one you'll find yourself using is called a fit range node. And this is very much like a remap range or map range node in other software. I could stick this right after the noise, and you can see I have a source section and a destination section. This is a lot like sort of adjusting levels in Photoshop. So this noise is sort of producing values that aren't quite up to the level 1. So I could reduce my source max here, and as I bring this down, now I start seeing that red come into play. So if I put this at 0.5, we can see that red. By default, some noises will have different ranges, so they might be 0 to 1, they might be something like -0.5 to 0.5. You could consult Houdini's documentation for that, or you could just lay down a fit node and sort of experiment with the range to get the results you want. So now I've recreated attribute adjust color node with way less parameters and functionality. Wow, good job. Well, let's see why we might do this. What if we wanted something like the position of the points to start changing based on the color? That's where, like, as soon as you start sort of looking outside the scope of this node, we're going to need to introduce a more customized approach. So let's double click on the VOPs here. And I'm also going to have the noise affect position. I'll have it displace the geometry. So I can type in displace along normal, and I can pipe in that noise to the amount of displacement here. And I can pipe in the position to position here. So I'm piping in displace position to position. And now you can see I'm getting this displacement of points based on the intensity of the black to white values. So I'm essentially just using my noise as a displacement map if you're familiar with some texturing basis. That's cool. And I have different attributes here. I can adjust the scale of my displacement. I could play around adding a fit range node before the amount 2 and start clamping these values. Let's say I bring up my min, and now it's sort of like I have some mountains that are jutting out of an ocean. I could go back to my colors here and play around with how that is starting to look. And I get my own sort of customized look here. I could try this out on other geometries since Houdini is all procedural, making it super powerful to play around with these different results. I'll up the scale of this sphere a little bit. And I'm going to change my lighting just so I can see, and I have this little wonky sphere. I could then jump into my noise here, maybe play around with my frequency, start upping my frequency quite a bit. I can tell I don't have enough geometry on my sphere to really get the fidelity I want. So I could up the subdivisions here. Maybe I'll really start cranking it. And I'm going to really crank it up here. All right, so now I have this little spiky ball. Maybe I went too high on the frequency. I'll start reducing that back down on my noise. All right, I could adjust my fit nodes here. Now I almost have the start of like a meteorite or a little planet setup, and I could start playing around with this and create some different effects. All right, so that's VOPs. That's a very, very basic preliminary introduction to VOPs. Incredibly, incredibly, incredibly powerful tool in Houdini. Now, let's look at how we can use VOPs in conjunction with a very basic simulation. So what is simulation? Essentially, simulation is different in the way it processes data. Let me try to explain this in layman terms. Simulation is time dependent. So each frame of a simulation is dependent on the previous frame. So think about something like building destruction or something. Let's say you simulate a rigid body simulation where all these pieces are falling around. Each frame of data is going to influence the next frame. So the shards of the objects or the fracture geometry will be at some point, and then you'll have things like gravity and physics that are driving the position of them, and Houdini has to know the last frame's position in order to calculate the current frame. So simulation is very much time dependent. That's sort of the main difference of simulations here in Houdini compared to like keyframe animation or procedural animation. So let's look at that in practice here. So by default, the most simple simulation in Houdini is the solver node, which is essentially just a blank framework for creating simulation. So let's look at something we did in that lava lamp tutorial, but we'll use a point VOP instead. So I'm taking a sphere here, I'm turning it into a fog VDB. So I'm using VDB from polygons and just checking fog. And then I'm using the scatter node to scatter points within that fog. So now I just have some points. You can create points however you like. That's just one way of doing it. When I pipe those points into a point VOP, and I use the same sort of framework here, I'm bringing in the positions of the points, and now I'm moving around the position with a noise. The one main difference here is instead of using a displace along normal, I'm just directly adding the noise to the position. So if I sort of show this in a grid again, I will take the grid, add a point VOP here, and I'll use a different noise. Let's use an anti-alias flow noise, which is one of my favorite noises. And I can plug the P to position just like the unified noise, and I can pipe the results to CD, and you can see we have this black and white noise. If I add that noise to the position of the points, so I'm going to take the position of the incoming points, and I'll just add that black and white noise right to it. You can see here, I'm going to stop routing the color, all the points sort of moved on the positive axis in one dimension because this is a one-dimensional noise. If I turn this to a three-dimensional noise, now these points are getting shifted every which way. And if I route that noise back into CD, you can see here we get all these different colors, red, green, and blue. And if you look down, oh, you can't actually see it if I move my webcam here. If you look at the XYZ position here, we actually have it color coded. Red is X, blue is Z, and Y is green right down in the bottom left corner there. I'm going to move my webcam back. That is what's happening here. It's moving these points based on this value, which we're just visualizing as color, and it creates this displacement effect. That's cool. I could animate that effect. I could adjust the flow and get some interesting looks here, etc. So now if I jump back to here, I'm doing that exact same thing, but I'm using a curl noise, which is a very nice noise for sort of getting some nice flow, almost like water-like movement to your noise. And instead of just using the position, I'm also using time. So I'm using this node vector to vector 4. That just means instead of taking 3 values, x, y, and z for position, I'm taking an additional 4th dimension, which is time. So I'm routing time into the 4th dimension. Whoa. And now when I press play, that noise is animated, so it's moving. And when I add that noise to position, I've created this little like gnat swarm here. And I could multiply time to get a faster swarm. So if I plug in a multiply constant here, I could turn it to 5, and now it's like insane. I could turn it to a slower swarm if I do 0.1 to slow down time. You could hand keyframe a parameter to create this look. You could promote different parameters on your noise. If I middle mouse on any of these dots, I can say promote parameter, and just like the ramp, now I have this little control that is visible on the top level of my VOP here, so I could animate something like the amplitude and have a different effect of this look. This isn't a simulation. This is just procedural animation. I can jump around on the timeline here, and there's no caching or thinking needed. It is literally just creating a new position in space based on the time value. It looks continuous. It looks like it's based on time just because time is continuous, but it's not a simulation. The previous frame isn't needed to calculate the next frame. I can just click around and everything's working. Let's look at what happens if I just copy paste this node and put it into a solver. So here's the solver node. It also has multiple inputs just like your VOP. If I double click on this, you can see the main thing here is that we are greeted with this DOP import. So we're in a dynamic context here, or DOPs, dynamic operators. So this is taking in the previous frame, all the geometry and data from the previous frame, and then we're doing something on that geometry. In this case, we're adding noise with the VOP. So I literally just took this, Control C, Control V, and I just plugged this in. And then I plugged it into the output. So that is outputting the results of that to the geometry, and then we're creating this little feedback loop. It's very much like a for loop, but in time. So now when I preview the solver and I press play, instead of creating just like a little swarm, these points are continually drifting farther and farther away because that noise is getting added cumulatively on top of each other. And we're going to be creating these very interesting swirling patterns. Usually when you're using a simulation or a solver here, you're going to want to cache those results. So it is good practice to put a file cache node down. I'll just do this for demonstration. And you can specify the location here. By default, it's going to create that automatically based on what you write in these fields. You could put explicit and manually select a folder location as well. And then you would select a frame range and it would cache it. So I'm not going to do this for now, or I'll go ahead and recache it just for fun. I'll just press save to disk. This is an easy simulation, so it doesn't really take that long to cache, and so it is already completed. If it's something like a fire or water simulation, that might take all night long, but this just takes a few seconds because it's a very simple simulation. And now I have a cache of these first 240 frames of these points sort of meandering around in space, moving around. Nice. So the backbone of this effect is based on that. That is sort of the growth that we're using. Now let's actually get into building the visuals. So I'll bookmark this part as start of the actual tutorial. So this is the backbone. We're using points and VOPs with a simulation to create this interesting movement here. The other major part of this setup is the use of the trail node. So I'm going to just build a little setup off to the side here so we can do it from scratch. So I'm just going to kind of drag this out to the side, and I'm going to use a trail node. So trail node is really nice. You can use it to calculate things like velocity, but you can also use it to make trails. I hit my mic. So instead of using preserve original, I'm going to use connect as polygons. And The trail length determines how many frames the trail will last for. I'm just going to do 240 so it lasts the whole time. You can see it forms this like weird jumbled mess of geometry. If I uncheck close rows, it will create these lines. So this looks very sort of interesting in and of itself, right? So if I disable I'm going to go back here and disable my file cache. You can really sort of customize the look of this. I could go back to my scatter node. I could try using less points, and I could click on my solver and say reset simulation, and that will give me a more sparse setup. I could try to start with a different shape. I could go into my noise and affect the frequency of this. So let's up the frequency, for example, and then press reset simulation. And now I have like this really sort of high frequency, almost like frazzled looking noise. And I'm just gonna look. I get paranoid sometimes I'm not recording. No, I think we're recording. So a lot of customizability here. I'm just gonna re-enable my cache, and let's sort of look at the next steps here. But you can see I have trails, and it looks like this interesting sort of growth. And this is largely what I based that second animation on, of like the white sort of blobby growth. The first animation, I'm doing some other strategies here, which I'll show you now in a second. So in this first animation, I have the growth sort of stuck to the ground, and it won't go below a ground plane, and then it only grows upward. So how do we do that aspect of it? Well, I'm going to move my trail node down a little bit, and I'm going to recreate this setup right here. So I'm going to use what's called a ray node. So if I put down a ray node, this node is super powerful. It essentially just sticks some points onto some other geometry, like a ray gun. So it just shoots it towards this other geometry and it sticks. So let's say I try this out with a sphere, for example. So I'm going to put a sphere in the second input, and I might make this a little bigger. And on the ray node, if I set this direction source to, or sorry, the direction type, the method to minimum distance, it will just stick these points to whatever point is closest to them. So it'll make something like this, and this isn't really that stable because these points are sort of jittering and bouncing to whatever closest point they see. Instead of doing it that way, you could use some sort of attribute to project the rays in a certain direction. So that is what I was doing. So I'm going to go ahead and put down a grid. And I'm going to create some sort of direction for those points to go. My cat was sitting in my lap this whole time, and now he's by the door meowing. Tom, come back. We'll see if he comes back. So, or maybe I've been lying about the cat the whole time. We'll see. To be continued. So now I'm going to make an attribute here. So I'm going to say attribute create. I could also create the attribute with VOPs. Lots of ways of going about this. And I want to create a normal. So I'm going to name this attribute N for normal. And I'm going to specify a direction. And in this case, I'm going to just have it shoot straight up on the y-axis. So I'm going to put y as 1. I could click on this little visualizer right here for display normals. And go ahead and toggle my normal. For some reason, oh, it wasn't working because I need to change the type to vector. And now I can see my normals here. 1 second. Okay, sorry about that. My cat was making some noise at the door, and I had to let him out. I swear I have a cat. I wouldn't lie about something like that. Maybe we'll bring it in by the end of the video here. All right, so where were we? We have the normal attribute declared. So this will be the direction that the ray node launches the points towards the geometry. So let's look at that in practice. If the points are essentially below the grid, they'll get launched upwards and stick to it. And if they're above the grid, they'll just do their own thing. So if I go ahead and have this set to normal, transform points, all that is good. Let's go ahead and see what happens. Now we see the points stick to the ground until they reach above it, and then they start floating and getting taken up by the noise. So if we trail that, I'm gonna just set my time slider to 240 frames here. So if we trail that, we get that look where the trail is stuck to the ground and then it starts rising to the sky. Now we could do some interesting things, like if you had terrain or something like that, you could add a mountain node, which does the exact same thing as what we were doing in the point VOP, and adjust the position of that grid here. And those trails would then stick to that ground plane. So now you can see that these lines are following the contours of the ground, which is pretty interesting. Kind of hard to see it that way. I'll just merge these two streams together just so we can get a better look at that. So you can see the lines are stuck to that ground. Okay, but for this example, I just went with a simple grid. Now we have to think about building the geometry. So we have lines. This could be an interesting effect just with lines. But I was wanting to have more of like that fleshy thickness to them. So we do a few more things here, and we'll use some more VOPs in the future here. One thing that I didn't do in the example where it's more of that white abstracted floating growth is I just let it play with the simulation, which is okay to do, but down the line it made some results a little bit trickier. I will go back to that, but that is what's happening here with these nodes. But let's just plow forward for a second here. To turn a line into a thick geometry, there's a few ways of doing this, but one is the polywire node, and you can see that adds in this sort of cylindrical geometry to the wire, and I can adjust the radius here. And I was just clicking around because I'm trying to see why my lighting is a little wonky here. Let me just add a normal node. There we go. So it just wasn't, it was smoothing the results, so we couldn't see the surface because it's a cube. I could also add more divisions here, and then we would get these tubes. So polywire is one way of doing that. Sweep is another way of doing it, and you could specify like a custom cross section. So it has a little more capability, but either way does the same thing. I'm going to uncheck stretch around turns, which is doing that. This requires a little more setup than the polywire, but it's more robust. All right. So in my example, I have the thickness of these lines adjusting based on what's called a curveu. So I wanted the lines to get thinner at the tips where the new growth is occurring. So what I do here is I add a resample node, and I check this curveu attribute. If I uncheck all these other boxes, this resample node, all it's doing is it's creating a curveu. If I preview that, you see this color is representing the U attribute. If you think like UV, this is the length along the length of the line. So you can see it starts blue and ends red. So at the base here, it's 0, and at the tip where it's growing, it's 1. So we can use this curveu attribute to adjust the thickness of the polywire here. So I could theoretically just go in here and we have this attribute drop down. I could select attribute for wire radius. By default, it's looking for pscale. If I typed in curveu, you can see it's getting very thin at the ends and staying the same at the growth area. I guess this would be the end and this would be the start. I'm going to leave this to pscale, and we're just going to manipulate this attribute within VOPs. So this is a great example of more VOP use. So I'm going to go ahead and put down a point VOP here. I'll put my display flag on the normal just so we see a bit of the shading. I'm going to plug in the point VOP. And now we're going to bring in a custom attribute. So by default, we don't see curveu on the left here. How we can bring in a custom attribute is with a bind node. So I'm going to just press tab, type in bind, and click enter. And you can see we get this bind. So I can use this just to reference anything. In this case, I want to reference my curveu, so I'll type that in for the name. And you just want to make sure the type is correct. So curveu is indeed a float because it's just one value, 0 to 1. And if I pipe that into something like color and turn off my visualizer, now we see that black to white value along the curve. But we don't want to map it to color diffuse. We want to map it to pscale, which determines the thickness. So I don't have to use any of these nodes if I don't need them. I'm just going to drag them up there. So I'm going to lay down a bind export. So if you want to export an attribute, you use the bind export. Bind brings it in, bind export pushes it out. So I'm going to name this pscale, enter, and I'm going to map my curveu to my pscale. All right, let's take a look at the normal node here. And you can see we're getting that same exact look as when we manually typed in curveu to the scale attribute. I'm going to go back into here, and instead of just having it straight 1 to 0, I'm going to add the fit node so I can adjust things a little bit. So I'm going to swap the destination min and max. So I'm reversing the scale, so it starts large and then ends small. And so when I animate, we get this sort of tendril formation happening. On my normal node, I'm just going to, just for display purposes, you notice all this little like faceting. If I change this to points, that'll give us a much smoother look here. Okay, so jumping back into my VOP, I'm just going to name this pscale to keep it straight, jump back in. And I could adjust the start and end values here just like so. And let's say like I wanted to have a little growth throughout the animation. I could promote my min, or I can map time to this. I could do a lot of different things and then animate the thickness of everything getting a bit thicker over time, which I did. But before that, let's sort of vary the thickness a little bit. Right now it's a little too uniform, so we can do this with another noise. So I'm going to go ahead and lay down a turbulent noise in this case. And I will just add that to the output of the curveu. So I'm going to, let's see, I forgot what I used to drive this. Let's see what I did in my example. If I double click on here, we have some more complex stuff going on. But yes, I am indeed using the curveu to drive the turbulent noise as well. So we'll get like sort of like lines, varying lines of thickness along the length. So if I jump into here, instead of using position, which would sort of get maybe some swimming noise, we can go ahead and try this. I'm going to go ahead and just put in an add and add the turbulence here. Notice how we now have varying thicknesses. So if I adjust the frequency here, you can see we can get like a lot of like bulging throughout the curve. But if I sort of look at the animation, you know, that looks all right, but you see the thickness isn't sort of moving along with the animation. You can see it sort of moves into the thickness, and that's it. It just sort of, that little bulge stays static where it is. I wanted the illusion of like it's almost pumping through the vein. So if we use, instead of P to drive that, we could try the curveu attribute as well. And now we get the bulging moving along with the growth. So it's like it's sort of growth. Either way would work though. So now we have this sort of tube with multiple bulges, and it's sort of like pumping as it grows outward. And I could go back to my frequency and adjust all these attributes to get different results. I could adjust the amplitude if I wanted to get more bulged. If I didn't want it so bulged at the ends, I could also use this curveu like as a mask for my noise. So I could add a multiply after my noise here and use curveu to modify that and add a fit range. And you see by default, now it has no noise at the base, and then it gets bigger and bigger and bigger. I could invert that. So this is much like using like a blending mode of multiplication in Photoshop. This is sort of like we're compositing within VOPs. And I could kind of tweak the output. So now I have maximum amplitude at the base, and then it gets a little less amplitude at the top. So we get that sharp point still. Just to touch on some little things I did before I move on here to get this to be a little more like stable. I mentioned I was doing a little bit of a, I was using a time shift here to pause my animation. So let me just show you how that works. I noticed that when I did it with this method, if these points moved a little too much, I got a little stepping in my shading. You can almost see it down here. See how it's almost like we get a little bit of jitteriness to the bulges. That is because we're just we're moving in the simulation a little too far. It's not like a continuous step. So what I did to prevent this, sorry if that's confusing, everything will still work if you don't do this, but I added a time shift node before my resample. So if I stick in a time shift, this lets you freeze a frame. So if I right click on frame and just say delete channels, now I can input my own frame, and I'm just importing the last frame of my simulation, which was 240. So now we just have like a static sculpture. If I scrub my timeline, nothing is happening. And instead of animating it with the simulation, I'm gonna use a Carve node. So I'm gonna stick a Carve node after the resample here. And this node is really cool. It lets you just kind of cut through a line here. So instead of animating the first U, I will animate the second U. And you can see I can just keyframe this attribute. So maybe at frame 1, I have a little growth. So I'll alt click on that at frame 1. And then just for speed, I'll just do 120. And now I have auto key on because I have this little auto key changes box from this drop down menu next to the keyframe. I now have 2 keyframes and I have this growth here. What this allows for is on my resample node, I can go ahead and up the amount of points here so they're even across all my curves. So I can go ahead and just check on maximum length and put this to something somewhat small so I have a lot of resolution to these curves. So I won't get that stepping, that kind of jitteriness to the animation that can happen with the straight simulated results. Okay, so that's a little bit of a little aside there, just to get a little more stable simulation. So now when I look at this, I should have very smooth sort of looking results. So if I look at like these bulges here, we don't get any sort of jittering as this animates. So notice now that I switch to this Carve node workflow, I'm not getting the tapering anymore. That is because before my curveu was essentially getting recalculated based on the length of the line. But since I have this resample happening before my Carve node, that curveu attribute isn't updating. So if I preview the curveu, just so we can see that, notice we're just sort of revealing the blue to red here. When if I disable my time shift and just look at the resample, before that curveu was automatically recomputing for the length of this line. Okay, as I was explaining that, I thought this sounds confusing as hell. So I made this little visualizer to make this abundantly clear. So I have the same exact line with the Carve node, and the version on the left there does not have the pscale remapped. So you see how we are just revealing the gradient. It is not actually changing size with the Carve. And then on the right there, we are remapping the gradient. So it's always based on the current length of the line. So you can see on the right, we're always going from blue to red. But on the left, we are just revealing the curveu attribute that's on the final geometry. So I need to reintroduce that back into my point VOP. So this is a little, I almost didn't want to say this because it's a little bit confusing, since it's sort of, we're trying to fix one thing, but we introduce an instability to something else. And sometimes this happens when you're dealing with setups and you sort of have to adapt some of your workflows here. So pretty easy fix. I can go back into my my VOP here, and instead of using my curveu to drive everything just straight, I can refit it to this range. So I'll go ahead and put a fit node here before everything, and this is like my main fit node for my curveu, and I will promote my source max. And so instead of having that 0 to 1, and 1 is the end of the line, I will make the source max wherever my Carve node is. So I'm just going to copy this parameter, right click on it, press copy on my Carve node. And then on my pscale VOP here, I'll just paste this. If I open this menu a little bit, I'll see this parameter we just promoted. I will go ahead and right click paste, paste relative reference. And I will go ahead and click on the info and just check on pscale. Notice now I have that blue to red gradient evolving with the length of the line. So it's not flowing through the curveu. It is actually updating like it was before. Now, that is completely optional. That's just the aesthetic I wanted, but it's really up to your artistic discretion. I'm going to go ahead and re-plug in the setup with the noise, and now we're getting this sort of noisy curveu as it evolves. And now when we apply that to pscale and look at it with the polywire, I do have this sort of bulging growth, and as the weird stuff grows, I do have the noise sort of getting pushed along the curve rather than it just sitting statically on the curve. Okay, sorry about that bit of an aside there. So now we have the geometry here, and we're going to just apply the same VDB principles now. I'll turn off my color visualizer to this. So if we look on my setup to the left here, the last part of the setup is simply turning these sort of geometric tendrils into VDBs. So instead of getting all these like overlaps and intersections, we just turn it into sort of one organic goop. That's sort of the look I want, like almost like the Last of Us fungi animation or something like that. I'm not going to go over these, but just know I'm in my setup. I added another point VOP where I just added more noise. So past that, it's really up to you if you want to add noise and do some displacement, how you want to manipulate the form to get some interesting effects. But after you sort of have the look you want, then you can use the VDB workflows. So I'll go VDB from polygons, and this will give us our surface VDB. Reference my lava lamp tutorial for an explanation of that. I will just make my voxel size a bit smaller to get some more resolution. And now we have the kind of merging of everything. You could add in some smoothing to this if you wanted. I could do a VDB smooth SDF and plug that in. And you can notice if you get too aggressive, you'll start losing some of the continuity of your curves. It's up to you what look you want, but if you want it more continuous, I might suggest a mean curvature flow operation and to lower your iterations so you just get a little smoothing. If you're still losing bits of your geometry, you could always go back to your VOP and increase the size of your pscale, or just increase the size of your wire radius here. So maybe I'll try 0.2, and that gives us this sort of thicker look. I could also think about adding something like a subdivide after my polywire if I wanted to try to smooth out some of the blockiness to get a little more cylindrical form. I could also think about adding a smooth modifier. So all of these are just shaping the look. They're not strictly necessary, and that's something you can play with, sort of all this post-processing of the geometry after the fact. So either way, we'll get some VDBs. You can smooth those out, and then you can convert that back to geometry with a VDB convert, or convert VDB rather. So I'll plug that in, and I'll convert this back to polygons. And so now if I press Y, we have this sort of dense mesh of polygons. And if I kind of jump around in my timeline, it'll take a little bit of time to compute. But we do have some interesting, weird, organic looking growth here. Yuck. Okay, so the last big step of this is the materials and shading. If I look at the info for my convert VDB, notice I have no attributes anymore. During this process, we lose stuff like curveu and color or anything that we made on the geometry. So you might want to transfer some of that back for shading. You can do that using an attribute transfer node, just like we've done in the lava lamp tutorial. So we want to transfer attributes back from our geometry stream onto our VDBs. So if I did something like just curveu, for example, and then I can look at the info and preview how that looks. Turn on my visualizer by pressing the visualization toggle right here in my viewport. I'm now getting my curveu attribute back. But notice it's like a little janky and aliased. In order to fix that, I can up my sample count so it's sampling more points. That'll help smooth it out a bit, so I up that to 10. I could also add something like an attribute blur after this. And instead of blurring the P, I could blur the curveu. And I could up the steps, or the iterations, and get a softer fall off. And now I have a curveu attribute I can bring into shading. And so that's the backbone of this effect. All the rest of the magic happens in Solaris or on the stage. I'm not going to do a huge walkthrough on that. I have other videos that cover how to procedurally shade. I recommend watching my worm milk tutorial. But just to give you an idea here of the basics, if I jump over to the stage context here, all I have going on is I'm bringing in the geometry and making a ground plane. I have literally just one light here and a camera, and that's basically it. The material for the growth, if I go ahead and go into here, it is all revolving around my curveu attribute and some noise. So I'm actually exporting that turbulent noise attribute. If I jump over back to the simulation here and go back to my pscale point VOP, instead of just exporting my pscale, I'm taking this turbulent noise and I'm exporting it to my own custom attribute called noise. And I'm using that within the shader to drive some of the shading. You could do that either way. You could export out any sort of attributes you want. You could make colors in your point VOP and bring that into your growth material. Lots of ways of going about this. But in the end, I just use that to drive some subsurface intensity. So we have parts where it's bulging are more subsurface or more like flesh-like, and then all the rest is a little less flesh-like. That's the effect. I hope you enjoyed it. I'll put a link to some of the auxiliary tutorials that I mentioned during this one. Hopefully this was helpful. The main takeaway here is VOPs are super powerful for creating shading, displacing points, doing basically any operation that you can't really wrap your head around with just a standard node. And anything you make in VOPs, you can use a bind export to bring it into a shader network. Super powerful, super fun to play with, and let me know what cool stuff you create with this. Have a good day.